Math with Mr. Williams, example 1, identifying an ordered pair. Which ordered pair corresponds to point T? We can clearly see here is point T down here. And if we start at the origin, and we're going to move right for our X number, so that would be 1, 2, 3, and then we're going to go downward 3 spaces to find the letter T. So X, comma, Y, and this would be a positive 3, and then we went down 3 spaces, so we're looking for an ordered pair that is 3, negative 3, and here we go. C is our answer. Math with Mr. Williams, example 2, plotting ordered pairs. Plot A, negative 2, 3, and B, 0, negative 3.5 in a coordinate plane. Describe the location quadrant of each. Okay, so the first one, let's go ahead and plot negative 2, 3. We know we're going to start at the origin, and we're going to move to the left 2 spaces, 1, 2, and then we're going to move up 3, 1, 2, 3. Here's our location, and that would be negative 2, 3. All right, let's go into B. B says 0, negative 3.5. So we start at the origin, and we're going to not move left or right because the first number is 0, but we're going to move down 3.5 spaces. So we're going to go down 1, 2, 3, and a half a space, leaving us right here as 0 and negative 3.5. All right, so which quadrant is each one in? Well, we know this is the first quadrant. This is the second. This is the third. And this is the fourth. So the negative 2, 3 is going to be in the second quadrant, and a 0, negative 3.5 is in neither quadrant, but it is on an axis. It is sitting on the y-axis. Math with Mr. Williams, example 3, reflecting points in one axis. So the first one is reflect negative 2, 4 in the x-axis. But we know to reflect a point in the x-axis, we have to use the same x-coordinate and take the opposite of the y-coordinate. So if the original is negative 2, 4, its opposite, it's going to reflect again the x-axis, would keep the x-coordinate, but put the opposite of that positive 4, so a negative 4. So let's go ahead and plot that. So we have negative 2, and then we go up 4, and there's negative 2, 4, and then we're going to go ahead and plot the reflection. So we have negative 2, 1, 2, and then we're going to go down 4. All right, and we can clearly see that it's reflected across that x-axis. All right, let's go to B. B says reflect negative 3, negative 1 in the y-axis. We know to reflect a point on the y-axis, we have to use the same y-coordinate, but take the opposite of the x-coordinate. So here we have negative 3, negative 1, and we're going to keep the same y-coordinate, but now we're going to do the opposite of that negative 3, which is a positive 3. All right, so let's go ahead and graph it. So we have negative 3, and then we're going to go down 1. So here is a negative 3, negative 1. All right, and now to reflect it across the y-axis, we're going to do positive 3 and a negative 1. And we can see this is now reflected across the y-axis. Math of Mr. Williams, example 4, graphing a linear equation. Okay, so we're going to first make a table of the values from the equation they gave us. So we have y equals negative 2x plus 1. So the easiest way to start off would be to look for 0. And then I like to go in order 1 and then a 2. So if we just use substitution to plug our numbers in, we have y equals negative 2, substitute the 0 for the x, plus 1. Let's come down here and do our work. All right, so we have negative 2 times 0. It's going to get us 0 plus 1. 0 plus 1 gives us 1. So now our ordered pair would be 0, comma 1. All right, let's go to the second one. Now we're going to insert 1 into the problem. Okay, notice we put the 1 inside the parentheses to show that substitution. Now let's go ahead and solve our problem. All right, so we have y equals negative 2 times 1. It's going to give us a negative 2. And negative 2 plus 1. The negatives win. They win by 1. So let's go ahead and put our number into the table. And let's write our ordered pair. So we start off with this time 1, comma, negative 1. All right, let's go down and use 2 now. Let's go ahead and substitute him in. All right, let's go ahead and do our work. Negative 2 times 2 is going to give us a negative 4. And we're going to add 1 to it, giving us a negative 3. All right, and our ordered pair then would be 2, comma, negative 3. All right, our next step is to plot those ordered pair. So we start off with 0, 1, not moving left or right on our x-axis, and then moving up 1 space. All right, and our next ordered pair would be 1, negative 1. So we're going to move right 1 space, and then we're going to move down 1 space. All right, and our last one is 2, negative 3. So we're going to move from the origin, move it right 2 spaces, and then down 3. And now we have our 3 ordered pairs plotted. So let's go ahead and draw a line through those points. And we can see they line up heading in the negative direction. Okay, one thing to point out here is this location here. This is what's known as a start. Okay, we can usually find that start for the y right here that's being added or subtracted to our linear equation. Now, if you notice, these numbers here are all decreasing by 2 each time. Well, we can locate that, which is called the rate or slope, as the coefficient in front of our variable. Math with Mr. Williams, example 5, graphing a horizontal line and a vertical line. Okay, on the first one we have graph y equals negative 3. All right, so we start at the origin, march our way down to the negative 3. All right, and what that means is no matter what my x value is, my answer will always be a negative 3. So you show that by putting a line horizontally across our graph at the negative 3. All right, let's start the second one. So we have x equals a positive 2. So we start at the origin and march our way in the positive 2 direction. 1, 2. And now we show that by putting a vertical line through the 2. That means for any y value, the x will always be 2.